Yeah, so I should start out by saying we're not Luddites. We're really excited about the new era of AI, machine learning, deep learning. It's going to be transformative, but there are some challenges associated with it, and one is kind of the black box syndrome I just want to talk about. May he rest in peace. Stephen Hawking's his fairly recent quote about kind of the potential excitement and perils of AI for society. Let's skip past this. Earl showed a little bit of this yesterday. This is just our forecast for this part of the market out to 2021. The first shaded row there shows high performance data analysis, the larger category. And the second one is the subset for AI methodologies, deep learning, machine learning, and so forth, growing at nearly a 30% rate out to past $1 billion in 2021. And this is just the graphic representation of the same thing, showing that the deep learning part will overtake the machine learning part, we believe. Okay, so some challenges associated with AI and particularly deep learning. Good news is HPC really is at the forefront of R&D for these methodologies. But the ecosystem has been formed mainly around big companies like Google, Facebook, Alibaba, and so forth. One of the reasons is because they have access to enough data. Deep learning in particular isn't that accurate unless you have really, really massive data, which is not, as that quote from Glaxo on the left shows, which is just not easily available today in many of the markets. The benchmarks are not where they need to be yet, which for vendors makes it a little bit tough to make the sale. Kind of the first proposition is that we really can't teach machines how to think the way that we think because we don't understand yet how we think. So that's kind of out, but the machines can learn on their own, and they're also capable of teaching each other. That's been proven, so they're sort of capable of what, in a human sense, we would call culture, but a lot of it is opaque. These are just a few of lots and lots of quotes out there from people about this opacity issue with deep learning today. And I think one of the salient ones is in the lower left there. Consumers are to entrust their safety to AI-driven vehicles or their health to AI-assisted medical care. They'll want to know how systems are making these critical decisions. Big difference between the game and something where a human life could be in peril. When Google's DeepMind computer beat all humans at Go, Google really didn't know how that happened. It really was not transparent, but when the Uber vehicle strikes down a pedestrian, people really need to know why that happened. Lots of people are interested, the automakers, insurance companies, and the humans involved. Same thing when Watson did a great job in the Jeopardy contest beating all the humans. Who knew exactly why? But so far the experiments with deep learning machines in the healthcare arena have not gone very well. That they have actually produced wrong diagnoses for people, and it's not the machine's fault. There was a human element in there, a bias that kind of crept in. So the National Highway Transportation Safety Administration in the US has been looking at this for a couple of years now, and what they say so far is that, yeah, we may not know how these cars make decisions in real time, but at least we ought to have some kind of a data recorder there so we can reconstruct it and study it, as happens with in the airline industry. Last summer, Germany passed a very pioneering law governing autonomous vehicles, the first national law in the world And they had people there, religious people, ethical people, people from ethics backgrounds and so forth. And what they said is that every self-driving car operating in Germany, no matter whether it's from the US or whatever, it has to be designed so that a human has the ability to take control. So it can't be like a tier 5 car. They also said something very important for automakers in particular, that if there's an accident and the car is in control, the automaker is liable. That's a big, big statement. Also, they can't be programmed demographically so that they prefer, if there's no choice, to harm an elderly person rather than a newborn. Something that happened just last month is China is putting together a national law for self-driving cars, and they have invited Eric Hilgenberg, who is on the Ethics Commission for Germany, to come over and advise them. So, here are the approaches to this solving this transparency issue that are happening today. Manual testing, adversarial testing, tweak an image, and I'll get to the last one in a while because it's sort of the most promising. But those first two, you notice that it says image, image in each of those. I mean, this is one of the things we have to, I think, realize that we are really at the very, very beginning of this era, and there's a big difference between applying these kinds of methodologies and technologies for bounded problems like facial recognition, voice recognition, to then much, much more difficult unbounded problems. There's a big difference between asking a computer to read MRIs to look for microcalcifications, early indications of cancer, and asking the computer to cure the cancer. Big, big gap between those things. Machine learning's been around for a while. I mean, remember that in 1993, 25 years ago, George Mason University Hospital in Washington, D.C. got a Computer World Smithsonian Award for programming a computer and routinely using it to spot microcalcifications in digital images. So it has been around for a while. That last one is the one that's particularly interesting because Deep Explorer methodology there, because what they're doing is they assume that neural networks most of the time make the right decisions. So they pose the question multiple neural networks, and the one that is the outlier, they retrain to agree with the majority. One other issue that needs to be overcome is catastrophic forgetting, which is when a neural network makes a mistake, it tends to keep making that mistake over and over and over and over again. And if you try to correct on the fly, it can lead to catastrophic forgetting, which is kind of forgets everything it's ever learned. And it really is the equivalent of, in a professional tennis match, if somebody moves the nets while the players aren't looking, if they move the net 6 inches, all of a sudden the players don't know how to play tennis anymore. That's catastrophic forgetting. So this is what we're doing, some massive studies on AI, including ADS, right now. And this is kind of the picture that's emerging. Is we'll see the kind of the data recorder at the vehicle level, very dense networking locally, sometimes assisted by drones, and then kind of the flight control pattern where a center like this one here will control traffic in a local area. If a vehicle leaves that area, control is handed off to the adjoining area. And simulation is not going to go away. There are some things that simulation is very, very good at that we don't see happening quickly with anything else. And that's it. Any questions?